Okay, so today we're going to look at what's going to be on the quiz, and then we're going to talk about how graphs can tell stories and how to use technology to create a list of function values. So first of all, this is what's on your quiz tomorrow. It's going to be from sections 1-1 through 1-3. It's 20 points. Okay? You can only use a scientific calculator, so don't use a graphing calculator tomorrow. I will have some extra scientific ones around if you don't have one. Evaluate an expression with given values. Use the order of operations to simplify. For example, some possibilities are, if I said here is our function and I want to know what f to the second is, can you do that? Okay? Evaluate a sentence with given values from a word problem. Same type of thing, but with a word problem. Identify whether or not a given list of ordered pairs is a function. So I have 2, 3, 4, 6, and 2, 3, 4. Is that a function? No, because 2 is repeated. So you should be able to go from the list and say if it's a function or not. Identify from a graph if it's a function. I have two different graphs here. One looks like this, the other one looks like this. Which one's the function, the left one or the right? Not the right, the left one, yeah. Because remember, if I go to this point, let's say this is x of 1, it has two possible values of y's, okay? Evaluate a function at a given value. So that's more of this type of thing again. Rewrite a function in its alternate format. So remember, we can say f of x equals x to the third plus x. Or I could say f colon x as it's approaching x to the third plus x. Okay, you need to be able to go between both of those types of notations. Okay? So here's what I recommend you do for the evening. If you're not sure, go over these problems. Okay, here's another one right here. If you know the problems, don't waste your time on them. Just do the ones that you're not clear about, okay? And check your work to get ready for this quiz. Right? Okay, so this is the very first story problem that we'll be looking at with a graph. And this one, it says, Frankfurter rode his bicycle to Chuck Rost's house to plan a back-to-school picnic. You guys see the puns in that? Frankfurter, Chuck Rost? Ha, 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 ha. Okay, the boys then rode a short distance to the park and then back to Frank's house. The graph models Frank's trip, where t is in time in minutes and d is in distance from home in miles. Which variable of the function is a function of the other variable? So express this in f of x notation. Well, what am I going to put into the formula? It's always the horizontal line, okay? So in this case, we would have f of t, right? And that's going to equal d for distance. Right? So in this case, the distance to home is a function of t. State the domain and range. What are my possible x values? Well, let's look at the graph. In this case, we're looking at t's, by the way, not x's. So it would be t such that, let's see here, t starts at 0. So I'm going to say 0 is less than or equal to t. And then the maximum value is 21. So, oh, 210, I'm sorry. Ends up here, okay? So that's our domain. Our range is D such that, notice that here we are starting at 0 again. 0 is less than or equal to D is less than or equal to, what's our maximum D here? 12, good. All right. It says estimate Frank's distance from home after 60 minutes. Okay, so f of 60. If I go to 60 and go up to the graph and then go over, what's the estimate of that time? About 6 miles. Okay. Estimate how much time it took Frank to reach the first 12 miles from home. Well, here's 12 miles, so now I'm going to work my way backwards. I'm going to go this way this time till the graph meets it, and then go back down. So how much time do you think? 90. So f of 90 equals 12. Okay. The last question on here was, what is the significance of this little horizontal line right there? What happened during that time? He stopped. Where did he stop at? If you need to go back and read the story and do that. So he rode his bicycle to Chuck Roast's house to plan a back-to-school picnic. The boys then rode a short distance to the park. So where did he stop? At Chuck's house. He must have stayed there for a little bit of time. It looks like for about maybe 15 minutes. So what is the significance? He stayed there from about 45 minutes until 60. So those are the two endpoints. From 45 minutes until 60. They stayed at Chuck's house. So it's a matter of putting it into English, the story that's happening in the graph. Hopefully you guys got something like this. Okay, so once again, D is a function of T. You can write f of t equals d. Your domain should be between 0 and 7. That's your x values. Yes?
I don't know why, but on number, on letter B, why is on the domain, why is it 0 is less than or equal to then?
It can be anything in between 0 and t, right? Starting at 0, at time 0. It can be 0.5 minutes. It can be up to almost an hour. So that's why it's less than or equal to 7 or to t. So it can be anything in that, any decimal within those bounds, okay? All right, and then the distance is anywhere between 0 and then the top one here is 100. So that's why I get a bound of 100. Okay, it says estimate Maria's distance from home at 3.5 hours. Well, if you go to 3.5 and go up, it's an estimate there. It's about, I guessed, around 85 miles. You guys could have something a little different than me. Okay? You know it's more than 75 and less than 100. Somewhere in between there, okay? In the middle. Okay, estimate how much time it took Maria to be be 100 miles from home. Write your answer using f of x notation. Well, going over to 100 and then down, you know it's 4. Okay? And then the last question says, what is going on here with this horizontal line? Well, that's the time frame when she was at the museum. She was there for an hour and a half, starting at 1.5 hours, and she was there until 3 hours. Okay? A function does not need to be defined by a formula in order to create a table. A function can be defined simply as a set of ordered pairs. In this case, the domain and range is limited to the values of the ordered pairs. For instance, if I have the following. What's my domain? It's going to be x such that x is equal to 2, 3, and 4. Okay? Specific numbers. Okay? Range, in this case, is going to be y such that y is equal to 4, 6, and 8. In 2000, the CDC found that the mean height h in centimeters for girls in the U.S. at various ages of A, where h equals f of A. Some of these data are given in the table here. What is the domain of the function defined by this table? So the domain of A such that A is equal to what? 2, 4, 6, 8, 10. The range. That's the height such that height is equal to 85, 101, 115, 127, and 138. What does f of 6 represent? It's the height at age 6. The mean height at age 6. Okay? And that value happens to be 115 centimeters. What is the value of f of A at 138? Yep, it's 10. We know it's at 138 here, so we know that in years, that's going to be 10. Okay, the last problem on your notes is the same kind of thing.